Good morning, ladies and gentlemen. When it comes to accessing systems, compromised credentials, impersonation, and identity theft pose a serious risk. I'm sorry, am I audible? So compromised credentials, impersonation, and identity theft pose a very serious risk, and all the more so in the industry that this august audience operates in. I'm here to talk about some technologies, some solutions that can possibly help address most of these risks, specifically in the identity and access management space. So just to talk about how we traditionally have been accessing systems, our ERPs, core banking software, and any other enterprise application that we use, we have a username and password combination. This username password has served us well for a long time, but there are some statistics that I present here which establish the frailty of the password today. So we have, each of us accesses about 25 different services online for which we need to authenticate ourselves. We have roughly 6.5 passwords that we use. We keep changing them once in about 3.5 months or so. Passwords have to be more and more complex. They cannot be simple anymore. So when we access so many services, we generally end up using the same password for most of the services. Is this true for anybody in the audience here? And what generally happens is if we set a too complex a password, we tend to write it down somewhere, which actually makes it counterproductive, right? So passwords have served their purpose. We'll need to think about newer technologies or technologies which can augment the password in order to identify and authenticate ourselves. So 81% of hacking related breaches leveraged stolen or weak passwords. You'd be interested to know that 65% of companies with over 500 system users were never prompting their users to change their passwords regularly. Pretty alarming. And generally, as employees in an organization, we don't have any qualms about sharing our credentials with our colleagues. It is done so in good trust, good faith, but sometimes it falls into the wrong hands. So talking about authentication in general, what are the methods that we've generally seen? We've seen username, password combinations. We've seen username, password, and a grid. We are asked for a specific character string which appears in a grid in a particular row or a column. Then we have username, passwords, and tokens. We have OTPs, and finally we have a combination of username, password, and biometrics. So these authentication methods fall into 3 different buckets. So passwords are what you know. What you have are those tokens or the OTPs, so you need a device along with you. What you are is basically biometrics. So biometrics are with us all the time. So we don't need another device to be able to authenticate ourselves to a system. So combining a username password combination with a biometric could give a very strong technique of authentication. Some trivia here. Biometrics have been around for a long time. The first known use of biometrics for verifying a transaction was way back 2,500 years ago. In the Indian context, biometrics have been used in the 1850s. A gentleman by the name Mr. Konai actually affixed his handprint on a particular contract document to prove that it was indeed he who has taken out that contract. Excuse me. So that's the figure you see on the right side of the screen. These are some biometric modalities. Broadly, biometrics are categorized into two different types. We have physiological biometrics and we have behavioral biometrics. So biometrics basically means bio, something that has to do with me, and metrics, measuring those characteristics that I have. So physiological biometrics, we are very, very familiar with some of them: fingerprints, iris, face biometrics. We have palm vein biometrics, hand geometry. All of these are unique characteristics that each individual has. On the behavioral side, it is classified into what we do, basically. So I gesture in a certain manner, I type at a certain speed, each of us moves our mouse in a different manner, we park the mouse at a specific area on the screen. All these could help identify the individual, and these are categorized under behavioral biometrics. Now, which one is best? Which biometric should I use for my own application? So there is no best biometric as such. It all depends on the specific use case that we are dealing with. So on the right side, you have the choice of modality. There are 7 parameters which can help us decide which would help us the most, which biometric would help us the most. So talking about the parameters, the first one is universality. So if we choose a specific biometric, for instance, a fingerprint biometric, if there are about 7.5 billion people on the planet Earth today, how likely is it that all have unique fingerprints? It is very likely. So that's universality. So basically, whether that biometric modality is available across the entire populace is what we are looking at. The second parameter, uniqueness, how unique it is. So is it different for everybody? Permanence, how permanent is the biometric? Supposing I enroll myself on a system when I'm 25 years old, would it still work much later? Or as we age, as we go through life, does that biometric change over a period of time? Collectability, how collectible is that biometric? Fingerprint scanners are good. You place your finger on a scanner and you're through. DNA, you cannot say the same. If I had to sign in my attendance, when I sign in, if I had to give a blood sample or a saliva sample just to get a DNA print, it's not going to be very practical. So we'll have to look at how collectible that biometric is. Performance, the system has to perform very, very quickly. We cannot wait endlessly, a few minutes or hours or weeks for a transaction to happen. So we'll have to look at the performance elements on the system. How acceptable it is to collect a specific biometric in a society. So if I'm highly conscious about hygiene, maybe I wouldn't like touching a fingerprint scanner which many other people have touched. So how acceptable it is in this specific environment that we operate. And finally, we have circumvention, how easy or difficult it is to break into that biometric system. So all these parameters will have to be taken into consideration while defining the specific modality that is going to be used. There are some other terminologies that you would come across when you speak about biometrics. You would speak about identification. It's a scenario where I present a biometric and I expect the system to identify me as whoever I claim to be. You have verification scenarios where I probably input my username or my employee ID and then present a biometric. So the matching is done specifically against that particular record that exists. Or is it segmented? So I just present my department name maybe and present my biometrics. The system scans through all the employees in the specific department that I've input and identifies me, verifies me. Is it passive or active? So am I actively participating in the authentication process, or am I doing it very passively without probably being even aware that I'm participating in it? So these are some of the terminologies that you would come across. A quick explainer, we've always seen biometrics from the user perspective. Of course, the technology folks here have also seen the internals. Just a quick refresher maybe. So when we talk about a biometric system, the very first process that we need to go through is enrollment. So user has to be enrolled onto the system. What happens in this process? The biometric is captured. When I place my finger, for instance, on a fingerprint scanner, an image of my fingerprint is obtained by the system. Some quality assurance is done, quality check is done on the image. Then there's some kind of pre-processing that happens, and eventually a digital template comes out of this biometric that I presented. So this digital template is what gets stored in the database. So this is the first time that I get enrolled onto a system. And subsequently, when I need to gain access to my ERP software, for instance, I go through pretty much the same process. So presenting my biometric, pre-processing, quality assurance, and creating the digital template. And then there is an additional process of comparing my biometric with the one I have presented now with whatever exists on this system. Right? Then comes the authentication decision. So it's going to say yes or no. Yes, it's a pass, or no, it's a reject. Right? So there are a set of policies, thresholds, and these thresholds, basically what we'll have to remember is it's not like a password where there's a 100% match that is going to be possible. So in fact, it's never going to be a 100% match. There's always a scoring mechanism which comes into play, and it is something that needs to be configured depending on the use case. So if the use case is law enforcement or forensics, for instance, we would probably like to identify, we would like to have a greater margin for error probably. But when it comes to a financial transaction, we'll have to be very, very accurate. So we'll have to set the threshold very, very high. So those kind of differences come in, and the scoring system depends on it. Some more terminology: there are false accepts, there are false rejects. So false accept happens when I'm accepted as somebody else and not myself. False reject happens when I'm thrown out by the system. It keeps rejecting me. It's an inconvenience, right? So higher the false accept rates, the more vulnerable the system becomes. Higher the false rejects, it becomes an inconvenience. So ultimately, what should the biometric system deliver to us? So first of all, it should be able to identify very, very dependably, very reliably. It has to help me prevent impersonation. I should not be able to pass myself off as somebody else. Okay? Sorry. It has to provide enhanced security. It has to provide non-repudiation. There should not be any scope for deniability. So I should not be able to deny that it was me who performed a certain transaction, for instance, or a particular entry in the system. It has to be able to provide me audit trails or audit logs of everything that has been done on the system. And it has to be convenient. It cannot be too complex. User convenience is very, very important. The user experience is very, very important. It has to be highly efficient. So having said that, if we were to look at a typical scenario at work, I walk into the office, I come across the attendance device, I present my credentials there, then I walk to my workplace, my desk, I have to log into the operating system, I open up my laptop or PC, I have to type in my username and password, then I have to open the application that I'm supposed to be using. It could be an email app, it could be a CRM, it could be an HRMS app. In parallel, there is a set of administrators, server administrators in my office who are doing administrative tasks on a set of servers running in the data center or in the cloud. Right? HR is conducting a set of recruitment activities, and we have a lot of folders and files which are highly confidential, which have to be secured. Typical work scenario. So now I propose a solution which should be able to protect and provide reliable authentication at all these layers. So we have created a solution called Innate, which helps bring in that kind of dependable authentication at all these layers. We have a core software, and we have specific modules such as these that you see on the screen. BioAD to be able to protect my login into the systems in the office. It could be a Windows login, it could be a Linux environment. Right? So username, password, and a biometric. Two-factor authentication, protecting your enterprise applications. So you have username, password, and biometrics to be able to access different screens, log into the ERP, for instance, or core banking software, and also bring in the authentication element at transaction level screens. So maker, checker kind of scenarios are also possible. A single sign-on where pass-through authentication is possible into various applications that I'm authorized to access. Then we have a module called Biometrics, which specifically protects administrator access to the servers in the data center. So many a time what we see is there's a common administrator login, and there are various people in the team accessing different servers. It could be a DB admin login and a password, common password, so shared credentials scenario once again. So when you bring in the biometric authentication element, this problem is eliminated. You'll be able to exactly identify who has performed a specific action, an administrative action on a server, and also maintain a complete audit log, audit trail of all the actions that have been performed. We have a module called the event verification system. Now, when there's a large volume of recruitment that happens, for instance, and you have a multi-stage recruitment cycle, you have psychometric tests, you have technical tests, you have face-to-face interviews, coupled with the large volume, the number of candidates being met and screened going through the recruitment process, it is very, very difficult to make sure that the same candidate is actually going through all the processes. So many a time, it could be that I am not very strong in a particular area. I ask my friend to sit in for the test, clear the test on my behalf. It could be a series of sports events. For instance, I ask somebody else to play on my behalf, and I'm able to pass on to the next level of the game. So in order to prevent this, we have brought in this module called event verification system. Then we have a vault to protect our confidential files and information, encrypted vault. And finally, we have a time and attendance module as well. So how this time and attendance module differs from what we see, the commoditized version of it, is that this is a global module. It's a centralized module. You can deploy devices across several offices, regions, different time zones, different shifts, for instance, and still be able to manage all of these through this centralized application. So at every layer of the enterprise, we've built in a module. We've created a framework which we call Innate, which will help you bring in reliable authentication at every layer. So quick slide about the architecture stack. You have a set of biometric sensors which are connected to some host hardware. This host hardware could be a computer, it could be a tablet, it could be a POS system. You have an operating system running on this device. You have the device drivers to be able to communicate with the biometric hardware. You have a set of algorithms and a database which stores all these biometric elements that we spoke about earlier. Set of services which passes on information from different layers and helps with actuation as well. The UI through which the user uses the application, and the enrollment module which I described earlier to be able to register on the system, and the various modules of our Innate framework. Finally, you have your enterprise application which needs to be protected. So a set of security standards to protect the data which is at rest as well as the data that is being transmitted. Okay. So this yellow box encapsulates the Innate framework that we have developed. All these modules have been implemented at various customer sites of ours, including a few people in the audience. They must have come across some of these modules. So just juxtaposing this solution against the defense in depth model, the seven-layer architecture, seven-layer module of defense in depth, information security professionals would identify this model very well. So at the bottom layer, you have policies, procedures, awareness campaigns. Then you have physical security. You have fences, walls, right? Then we have perimeter security, and thereon we have the internal network, the hosts, the applications, and the data. So all the green text that you see there are the modules that we have within the Innate framework. So some of the tech that has gone into Innate, we'll be happy to have a conversation with you. We have a stall outside. We'll be able to describe this in greater detail. So why the framework? It provides audit trails. It has all the algorithms built in. It is platform agnostic. It is database agnostic. It has all these modules pre-integrated. You don't have to put time and effort, invest time and effort in trying to integrate all these different solutions together. Security and standardization. And we have a routine release in terms of a product approach. So some use cases, of course, we've done a lot of work in the Aadhaar ecosystem as well. eKYC, Aadhaar Pay, proving transactions. Inside the enterprise are the solutions that I've been describing thus far. So a quick snapshot of what Precision does as an organization. We are slightly more than 23 years old. Our biometric practice is about 12 years old. We have done a lot of work designing, developing, implementing, and supporting biometric technology-based solutions within the enterprise, as well as in the other ecosystem. Some of our other BUs, we have an Internet of Things BU. We develop solutions for consumer IoT, commercial IoT, and industrial IoT. We offer cloud solutions, we offer managed services solutions, and systems integration. Some of our customers. Thank you so much for your time and attention.